Welcome, everyone. I'm James Shore, and this is the Art of Agile Development Book Club. Today, we are discussing zero friction development. Ultimately, zero friction development is about increasing the speed of feedback and development, preferably to the point where we get feedback within a second or so of making a change. To get us started, I'll read an excerpt from The Art of Agile Development. As a reminder, the second edition is out now in both ebook and print editions. You can get it from Amazon by visiting jamesshore.com/s/buy-AOAD2, or you can find excerpts and bonus material by visiting jamesshore.com/s/AOAD2. Zero friction. When we're ready to code, nothing gets in our way. Imagine you've just started working with a new team. One of your new teammates, Pedro, walks you over to a development workstation. Since you're new, we'll start by deploying a small change, he says, sitting down next to you. This machine is brand new, so we'll have to set it up from scratch. First, clone the repo. He tells you the command. Now, run the build script. Command starts scrolling up the screen. We use a tool for reproducible builds, Pedro explains. It's detected that you don't have anything installed, so it's installing the IDE, development tools, and images needed to develop and run the system locally. This will take a while, he continues. After the first run, though, it's instantaneous. It updates again only when we commit changes to the config. Come on, I'll show you around the office. When you come back, the build is done. Okay, let me show you the app, Pedro says. Type run dev to start it up. Once again, information starts scrolling by. This is all running locally, Pedro explains proudly. We used to have a shared test environment, and we were constantly stepping on each other's toes. Now that's all in the past. It even knows which services to restart, depending on which files you change. Pedro walks you through the application. Now let's make a change. Run watch quick. It will build and test the files we change. You follow his instructions and the script starts up, then immediately reports build OK in green. Nothing's changed since we last ran the build, Pedro explains, so the script didn't do anything. Now, let's make a small change. He directs you to a test file and has you add a test. When you save the changes, the watch script runs again and reports a test failure. It takes less than a second. We've put a lot of work into our build and test speed, Pedro tells you. He's clearly proud of it. It wasn't easy, but it's totally worth it. We get feedback on most changes in a second or two. It's done wonders for our ability to iterate and be productive. I'm not lying when I say this is the best development environment I've ever been in. Now, let's finish up this change and deploy. He shows you the production change needed to get the new test to pass. Once again, when you save, the watch script runs the test in about a second. This time, it reports success. Okay, we're ready to deploy, he says. This is going into production, but don't worry. The deploy script will run the full test suite, and we also have a canary server that checks to see if anything goes wrong. Type deploy to kick things off. You run the script and watch it go through its paces. A few minutes later, it says integration okay, then starts deploying the code. That's it, Pedro beams. Once the integration succeeds, you can assume the deploy will too. If something goes wrong, we'll get paged. Welcome to the team. It's been less than an hour, and you've already deployed to production. This is zero friction development. When you're ready to code, nothing gets in your way. All right, let's get started with our first discussion prompt. Fast feedback is at the heart of zero friction development. Ideally, what you want for every change is to get feedback on whether that change worked or didn't work in less than a second. So the question I have for all of you is, what are your techniques for fast feedback, and how does that change the way you work? Now, there's been a lot of great discussion on the Discord, as usual. If you're not familiar with the Discord, you can join it by going to jamesshore.com/s/AOAD2 Discord. Trolling Monkey said, when I look for examples, I always turn to the video gaming industry. To have the visual editor on one screen, the code on another, and my creation live on yet another one, all in real time, where I can evaluate instantly what I see, hear, and feel, with all my senses, not just red bar, green bar. That's feedback. I thought that was interesting because I actually find that doing a manual check is slower feedback than I want. I like the green bar or red bar because I can I have my test set up so that they report success in typically a second or less. So I'm able to move really quickly with that feedback. But I have to admit, when I'm working with something really visual, then of course I am looking at it. And if I'm dealing with interactions, I want to see how it feels. So in that case, having that visual feedback is important. And in that case, I want it to be really fast as well. Jay Bazuzzi, along those lines, recommended Brett Victor's Inventing on Principle talk, and maybe somebody can paste that into the chat, which is a really interesting talk. I did watch it after you recommended it, Jay. Jay's on the line for those of you who don't see it. What was interesting about that presentation was that he was doing a visual of a little graphic of a tree. And when he made changes to the code, that change updated in real time, not even with a compile cycle. In fact, he could drag sliders back and forth to see changes in the make changes to the code and see those reflected in the visuals. Honestly, I'm not sure how practical that is for the kinds of software development I do, which has a lot of dependencies on there tends to be a lot of glue code. There's a lot of dependencies on services and so forth. And I don't want it running for real unless it's in a very controlled environment. But it was a great example of the kinds of benefits you get from fast feedback. And one of the things that Brett made the point of was that when your feedback is so fast, down to less than 10 milliseconds, really is what you're looking for in that scenario, is it allows you to interact with your program and be creative and inventive in ways that you really can't be when your feedback isn't that fast. Jay, thank you for stepping up. Welcome.
Yeah, I just want to riff a little bit on what we were just talking about. In your book, you say 1 second feedback for your test results is a good goal. Brett talks about smaller feedback times from that. I like 1 second feedback better than 10. I've heard teams or developers say, our tests are great. They're so fast. They only take 10 minutes to run. And I'm sure they felt very proud of getting down to that number. This is one of those things where if I can detect a delay, there's potential for improvement and value in doing so. Now, we might decide today isn't the right day to make that investment, but whenever there's any delay that I can perceive, there'd be something good out of making that delay less and getting that feedback sooner. So I don't put a hard number on it. We might say, well, if one test takes a whole second, maybe that's okay, but then our suite is minutes. I don't think that's a useful framing. Instead, it's, I made a change. How soon do I get the feedback from that change? And if there's a delay, then I have to do this cognitive effort to remember that change goes with this result. But when that delay goes away, then it's just I'm turning the knob and getting the result immediately.
Yeah, I completely agree with that. The numbers, I say 1 second, 10 seconds, 5 seconds. And that originally came from Jakob Nielsen's book, Designing Web Usability, which talks about usability research. And he says in that book that if something takes less than 100 milliseconds, so less than 1/10 of a second, it feels instantaneous. And I actually think he missed a beat there, because you really need it to be down to less than 18 milliseconds to feel fluid in terms of animation. But if you want animation or something to feel like it's in motion, you need it to be less than 18 milliseconds. If you want it to feel instantaneous, I think less than 100 milliseconds, it was his research. And then he said that it feels fast if it takes less than a second. And then if it takes more than 10 seconds, then people's attention will wander. They will go on to something else. And so in the first edition of the book, that's what I said. I said it needs to be less than 10 seconds and less than 1 second is ideal. But paying attention to that over the years since I wrote the first edition, what I found was that if it takes more than 5 seconds, it feels painful to me. And maybe that's just because I've gotten used to it being fast. Because honestly, like you're getting at, Jay, if it takes more than a second, it starts to feel painful to me now. Mm-hmm. But I definitely felt a qualitative difference between 5 seconds and 10 seconds. Mm-hmm. And that's why now I say it should be less than 5 seconds. And I keep pushing until my typical feedback cycle is less than a second.
It sounds like you've spoiled yourself, and I appreciate that. And I hope we can spoil more developers to think that 5 seconds is slow and would like to be faster.
Yeah. I'm working with a company right now that they have a lot of teams. And one aspect of the department doesn't really write tests at all. and another aspect of a department does. But I think but they are really pushing it, because when I see them do I sat with them, I watched them how they worked, and it took about 20 seconds for them to get feedback, 20 to 30 seconds for them to get feedback. And the folks who were doing tests were being really disciplined about it. They'd run the test and they talk about what was going to happen. They kept taking those small steps, but it just felt like, I don't think everybody's going to have this level of discipline to do this. It doesn't seem realistic to expect that people will see this unless they really value the tests. And that's in fact what I was seeing from this other half of the department, is they didn't really write tests, and their feedback cycle was something like 3 or 4 minutes, because it took the same amount of time to build and run the code, but now they're testing it manually. Mm-hmm. And so of course what they're doing is they're batching things up in a really big way.
Yeah.
Thanks for your comments, Jay. Appreciate it. Michael, welcome to the show.
Hi.
Hi.
Is the sound okay?
Yeah, you're great.
I was just thinking about what has been said. I think there are two different feedback loops. One is the test-driven, and that's probably where the 1 second time frame or maybe less applies. And to be honest, I think it's between 1 and 5 seconds could be okay. I don't mind little pauses just to relax, the mind while we are coding. And I don't need the feedback after every character I typed or something like that. Mm-hmm. And I was just thinking maybe what I value more, or at least equally, is the feedback you call from explorative testing. I coded something, but honestly, how many of these unit tests do have business assumptions encoded there? And so maybe it's worth thinking about, how am I going to get feedback as quickly as possible on what I'm building?
I think that's a great point, because of course, testing doesn't give you the answer, doesn't tell you that you know what you're doing. It doesn't tell you that you're doing the right thing. It only tells you that what you think you should be doing, you've done correctly. So having that feedback from the exploratory testing, I think is really valuable. It looks like Dan wants to chime in on this. Thanks for the comment, Michael. Dan, welcome.
Welcome. Good morning. Yeah, one way I like to think about this for software. Let me start off by saying, some companies I go to and say, yeah, that's nice, but we have something big and complex here. So there's no way we can achieve that because we're doing something meaningful and large. And I like to I think of it as this deviation from a known state, regardless the size of your thing. If you know what it is and it's in a good state and you make a small change, the more you can get feedback on that small change and contain it to what's occurring, the difference that it's occurring, feels like something small enough that can validate and get that quick feedback on.
Yeah, I absolutely agree. It's really about knowing, did the thing I just do work, right? Because if you don't know that, then you don't know if your code works, and that's a problem. And what I find is that when the feedback on that question is too long, then people make lots of changes before they start checking if their stuff works. And then when it invariably doesn't, because programming is hard and the computer's constantly kicking our butt, if you've made a big change, it's really hard to tell what you didn't do correctly.
I feel like some organizations get stuck in a state of they don't really know if they're in a good state, the large system. And so it really stood out to me in the first section about including the IDE, including the local development environment, like including those things in the known kind of understood, more intentional state. That seemed really powerful.
Yeah. And I think that aspect of organizations not really knowing if things work, I see that really commonly. And to really know, you've got to have a good test suite, because you might be changing this thing. going back to this company that's struggling, and I think a lot of their problems are down to this slow test development cycle. So they have to do big changes. One thing I observed as I watched them for the team that wasn't using test-driven development is they made a change, and they made another change, another change, and another change until they finished everything that they thought they were there to do. Then they went to check it, and it didn't work. And so they started looking into it and exploring around and doing the manual testing. And they saw something and said, wait a second, I think that was broken already. And then they had to go dig into that. And then that led to another thing that wasn't working. And they had to go dig into that. And there's this whole chain of yak shaving that occurred, which all comes back to, well, are you in a no good state or not when you start? Thanks for your comments, Dan. There's something else that came up on the Discord that I want to share. Sarah Horan Van Treese had a great response that I want to read here. And I see Sarah's on the line, so maybe she'll join in and expand on this a little bit. She said, I'm sure this is the obvious answer, but TDD. I have multiple feedback loops sequenced for fastest feedback. When I'm writing my new active test, I keep running just that test until it's written with a basic passing implementation. Then everything after that is a series of regression validations while I work through refactors. I use watchers to selectively run certain unit tests based on file changes several times a minute. And actually, in a follow-up conversation, what she said was that ran automatically based on file names. So if I presume that if she changed a file here, then it would run the test with the same file name over here. Then every couple minutes, I'll run a bigger suite of unit tests applicable to the broader module of code I'm working on. And then a bit less often than that, I might include longer running tests for the same module. In other words, tests with a database or partially integrated, et cetera. Then before a commit, I'll run all the tests and so forth. It's not just about test speed. The sequence also tells me about the quality of the code and of the tests. For example, if I refactor something and it doesn't fail the watch test, but it does fail another test in the module or an integration test, maybe we're missing a unit test that could have caught it earlier. If the test for a module pass, but tests for the whole code base don't, maybe there's an issue with coupling or poor module boundaries. It's also about making sure failures are really clear. If a test fails and I can't immediately tell why, I might look at what could be done to what could be done to error handling to make it more clear, and then fix that before I fix the issue, and so forth. I know I just regurgitated TDD 101, but it's so key to fast feedback. If I clone a new repo, the first thing I do is make sure I'm set up to operate this way. In terms of how this changes the way I work, I use lots of mocks/doubles. I pay attention to module and code organization, so it's easy to run subsets of tests. And I'm particular about the order of writing and running tests. So I thought this was really interesting, and partly because this, even though Sarah said this is TDD 101, this is actually fairly different than the way I do TDD. And we are going to have a whole book club session on TDD later. But I'd love to hear from all of you about how TDD fits in for you to this fast feedback cycle. And do you use it in the same way that Sarah's talking about, or do you use it in another way? And Sarah, if you'd like to chime in with some of your thoughts about how this works for you, I'd love to hear more from you as well. Hi, Sarah.
Hi. Yeah, I was interested when you said you're able to run the full test suite for you think you said something like 1,400 tests that in less than 2 seconds. That's I have done a lot of work in larger code bases where we're getting to where there's a lot of work to be done to get to the state that you're describing, the zero friction state. So I think a lot of the approach that I have has to do with what, like, the steps that we've needed to take as part of that journey from, of a legacy code base to that versus starting there with new code. But that's still the way that I kind of default to operate, even on some of the newer things that I'm working on, because for me that it's going so much faster than running the full test suite. I was so impressed with the speed that you said, 1,400 tests in 2 seconds. I went through several code bases just to run mine, just to see what I had in terms of stats for everything. And I had none that were less than, for a full test suite, that were that fast. So
Well, I should be honest. I do have a small suite of smoke tests in that same code base, maybe 5 or 6 smoke tests, and they take something like 3 or 4 seconds. So,
Okay.
so it's not all that fast. But those actually, for me, those are just like what you're talking about. I'll run my main test suite, which is the 1,400 tests, and then I only run those smoke tests later. I don't run them every test run, except I do have them set up if there's certain files that are sort of central that are hard to test with unit tests. So if one of those 4 or 5 type files has changed, then it runs the smoke tests automatically. But the normal day-to-day is only running those unit tests. In fact, just to prove that I'm not lying, I'll go ahead and share that. So I'll start from a clean build and then run the unit tests. So that time it took 1.9 seconds, and the whole build was 2 seconds. But if I were to run the whole thing, then yeah, it takes a little bit longer. Jay, welcome back.
I just wanted to say that the thing that I like in all of these stories, both what I heard from Sarah and what I heard from James, is that you are taking seriously the investment in your own development experience. It's not about are we this speed or that speed? Are we using the correct design or testing techniques? But that you are investing in that. You take we're going to make it better, and it's worth making it better. The investment we make will come back and pay off quickly, and so that's worth doing. And I really like that about both of those stories.
Yeah. I think that's key. Is the idea that we're going to truly invest. And that's actually going to be the recommendation I'm going to make to this company I'm working right now. I look at their code base, and they've been around for a long time. It is the best code base I've ever seen from a company of this size and this length of development. They're really, really disciplined about their work. Now, that doesn't mean it's perfect, because you can always find things to improve, but they're really disciplined. But they haven't taken that same level of discipline and applied it to the developer experience. So one of my main recommendations is going to be invest in your build, especially for the team that already has the tests. If they can just bring the speed of their test feedback down from 20 seconds to less than 5 seconds, that is going to make a huge difference to their productivity. I mean, since they're doing test-driven development, that could potentially double their productivity, because it's going to cut the speed of their feedback loop down by a quarter of where it is now. I'm going to move on to our next discussion prompt. I actually hope that you'll stick around for this one, Jay, because the next discussion prompt is that builds are a common source of developer friction, and people have mentioned liking the idea of installing the IDE and getting everything going. So what kind of problems have you experienced with inconsistent or unreliable builds? How have you fixed them? And do you use tools such as Nix, Bazel, or Docker to improve your build experience? And then on the Discord, Jay said, pretty much my whole job right now is to convert a large system of 100 teams from CMake to Bazel. Ask me anything. So Jay, I'd love to hear more about this. And this is a opportunity for all of you to ask Jay, because he did volunteer. Ask Jay anything about Bazel and his experience about that. Can you say a little bit more about it, Jay?
Sure. So one way to think about Bazel is we might classify build systems in 2 categories. In one, maybe we call it imperative. If I'm going to do a build, here are the steps for carrying out that build. And it's almost just like writing a script. And you can get pretty far with that approach to implementing a build. And then the other is, it's like about dependency analysis and giving the build system all of the knowledge you possibly can and letting it make decisions about what to do. And Bazel is in that second category. So it knows every input and every output and for every step in the process. It uses hash codes or SHAs for all these details. So it knows when anything has changed and what needs to be rebuilt. And so you can get a a hermetic or reproducible build where I build on one machine and I get a result, and then I can go to another machine and know that I would get the exact same result with the same inputs. And then you can build a lot of other stuff on top of that, like remote caching and remote execution. So you might run your build across a farm of machines in the cloud, or have an official build that produces a result that goes into a cache. And then my next build is much faster because I can take most of the input, or I can take most of the cache results from that previous build. And all that sounds really great, but wow, the investment you have to do to get to the point where your build is specified at that level of detail and correctness, it's so much. So we have I don't know how much detail I should go into. We have a team of experts working on this problem over a long period of time, trying to convert our build from one to the next. So it's quite an expensive investment, but we hope we'll get this big payoff. I would not recommend this for small teams and small projects. The overhead of becoming a Bazel expert and making that huge Bazel investment, I think, won't pay off. If your build is only a couple minutes, speeding that up with Bazel isn't going to help. If you're in the situation where your build is hours, then you have this potential to really get that return.
So what's for the company you're in right now? It sounds like this is a significant investment. What was the impetus that caused them to decide to do this?
Yeah, our build is hours. Our tests, our full set of tests that come after is also hours, and that slow time impacts the edit build test cycle locally on a dev machine, as well as the check-in process. So when you submit to CI, you have to wait a long time for that process to run, and those things are slowing down our productivity across the company. So making this investment, we hope, will get us these big speed improvements. There are some other things around governance and long-term maintenance reproducibility of builds that we also want. So if you want to ask the question, exactly which version of Log4j did we use in last year's release, that can be a difficult question to answer with build systems that are just effective but not Bazel-like. And with Bazel, because we know exactly what all the inputs were, we can pin that down precisely and know for every release exactly what all the inputs were, and so we get some like traceability and governance out of that.
What's it like with the test experience? So for the example that I showed, where it runs in less than 2 seconds, my normal build actually takes just a fraction of the second, because I have a dependency analyzer in there that I built, because, like you said, I take it seriously and I invest in it. And it so it can recursively know what any file that changes, which test that corresponds to, and so it will run just those tests. And I think Bazel does something like that, but I'm not sure how that works. Does it have that level of granularity where you can say, just run these tests based on this thing changing?
Yeah, it does. So it's not per test case, but it has some notion of like a test module, and it knows what all the inputs of the test module are. So if you change a source file, it knows which tests need to be rerun to produce those test results. And that mechanism is the same as the build mechanism. So you can cache test results, you can cache them across machines, and you can run tests in parallel with each other and with the build. So if you have a lot of build modules and a lot of tests, you might have a module at the root of the graph that you build first, and then while its tests are running, other modules that depend on that change are being built. So you get great parallelism between the build and test as well. So if you go up to your new dev machine, you first clone, you run build and test, it's a little bit faster than other systems just because of the great parallelization. But then when you run the second time, it's almost instant, and you just get this list. All the test results are green. From cached results, we're done. So the second time incremental results can be excellent.
That's amazing. Now, what do you do, though, so a major problem is, of course, that people have non-deterministic tests, and they have tests that are flaky and don't always run correctly. Now, this is actually, I feel, not a very hard problem to solve, but it takes a mindset that we are going to take everything that could be non-deterministic and wrap it up in a deterministic wrapper, and only use that deterministic wrapper in our tests. And or, of course, mock objects. So what do you do about these non-deterministic tests in that environment?
Yeah, that's a tough problem to have. One option is to say certain tests exist outside of this kind of highly controlled predictive environment. You can mark a test as being external, saying it depends on something that's external to the system, which is effectively true with any kind of non-deterministic test result. And then when you run the test, when you run your build and test script or whatever, it will rerun those tests each time instead of taking cache results.
Yeah, but if it's running those tests, since those are often the slower tests, and it's running them every time, that of course is going to have a big impact on your experience.
Yeah.
I really appreciate you sharing, Jay, and we might have some more questions for you, but I see Sarah has a comment. Sarah, welcome back.
I was just going to add, so this same problem has been something that I spent several of the last years focusing on and in multiple different teams. And it's so interesting to find, I was surprised to find as I went to, new job to find out, same problems, and then to hear Jay describe the same thing as well. I had at the beginning, we had same exact problem where it was hours to really get ultimately through a build and test cycle. And we had to do similar, not using the same tooling, but we had to break apart the tests. A lot of it you just described with like the non-deterministic tests. It would, would have to take a look at, there were 10,000 tests in our test suite. And it was just really a small portion of them that were problematic, but it would end up being, because everything was built together, you had it was as if it was a big transaction. So one thing fails and you've been running these things for a really long time, then you're starting back over from the beginning. And it's interesting to hear you guys talking about caching and some of the things to run selective tests, to try to just run those selective tests, because ultimately we found that was not worth, that wasn't worth the investment, because we got too many false cases where something about like having cached where that didn't give us the correct feedback, and we chased phantom ghosts like later in the cycle. And it turned out if we had just started fresh and rerun, that we would have gotten the feedback that we needed earlier into the process. And so for us, at least, we went and said, well, we're willing to take the time for everything to be a clean run, but let's segment it let's really focus on sequencing and stopping points, so that you have like a green here, then these are the fastest tests. We know for sure. Then we move to the next round of them. We don't have to roll back to this point. But having everything a fresh environment instead of some of the things that were supposed to be like performance optimizations, it did add, obviously we lost the performance optimization, but the cost of time spent chasing any issue that we could have been, that where it obfuscated the root cause, was a time that is, usually is much bigger and harder to quantify than the extra few seconds that we were, having from the performance. So it's interesting to hear that there was success with that, because I walked away from it thinking this isn't, I'm not sure why this doesn't feel like a feature.
Right. I wonder how much of that is related to the determinism you can have in your system. And a lot of people default to doing these sort of end-to-end integration tests, which are really, really hard to make deterministic. But if your whole test suite is composed of those, getting out of that is a huge ordeal. And I've seen companies that just sort of threw up their hands and programmed their test suite to just automatically retry 3 to 5 times. And then only if the test failed, every single test, if it failed, they'd run it again and run it again and run it again. And only if it failed 3 times or 4 times or whatever they could get to like 99.9% reliability, then they would fail the test build.
Oh, wow. Wow. Yeah.
Yeah. I don't love that. But on the other hand, from a sort of pragmatic point of view, the transactional, we have to get through the whole thing or nothing, can be a real problem. Jay, I'd love to hear your thoughts on this as well.
Yeah, I think that you've covered it pretty well. The the kinds of tests we have, they're going to affect our runtime and our reliability, and that matters a lot. And I'm looking forward to our all Bazel future, but even in conventional build system, that flakiness is going to hurt you. So it's still worth investing in. Hopefully, you've been separating your flaky from not flaky tests, and your fast and your slow tests, and figuring out your rerun strategy and investing in making things more reliable. So I don't feel like I have a terribly great insight to add around that.
Thanks, Jay. Sarah, I hope you'll stick around for a moment, because the next discussion prompt, we're actually running short on time, but the next discussion prompt is something that you said you had some experience with in the Discord, and I was hoping you might share some of those experiences if you can. And the prompt is about test data. So test data being a common source of build problems. Company I'm working with right now, the manual testing often fails. Even the manual testing fails because they have a single shared user acceptance testing environment and dozens of teams. So one team will change the test data, and then another team's in the middle of trying something and it fails. And so what do you do to manage your test data? And of course, anybody can answer, but Sarah, you said on the Discord that you had a lot of different experiences, no easy answer, but if you have any stories or examples to share, I'd love to hear them.
Yeah, so I think it depends on the kind of system, the nature of the system. Pretty. There's a big difference, I guess, in the types of things that I've been working on, and how that strategy was, how integrated, first of all, it is with other systems, and are there going to be other teams like sharing an integrated environment? Anything you can do in isolation, where you can control it, obviously is going to be a lot better. But if you need, some of the projects I've worked on, the nature of the system, you needed to have a lot of data preceded, and the database needed to have a lot of data already there in order to effectively run the tests, as opposed to other systems in certain systems are focused heavily on reads in terms of the types of things that you'd be testing. So you need to have an entire database kind of populated with a lot of different test scenarios to effectively be able to run through the data type of tests. Systems that have a lot more write activity because of the nature of what it is that you're building. Then you're talking about test scripts if it's going to be automated testing, and then you want to have data driven test scripts, which it's just very different. So I worked on something that had a lot to do with using search data against very complex permutations of big data sets. That obviously is there's no rights really in that. So the entire strategy could be starting with a data set before any of the testing begins. And then it was about optimizing the performance to do so. But we had to work in an integrated environment where the data was very dynamic. And so it was about making sure that it had to do a lot of data aggregation across different things. So we had to create a lot of tooling around making sure we could dynamically generate new test cases, because our source data was changing so rapidly underneath us. So I built the tool out just for that. That was the whole purpose, was helping us rebuild test cases because we had to invest in our development in our development process. But I worked on other things where the biggest thing to do was to make sure you had configuration data in place, because that was the nature of the system, or files. The file processors are the essence of what it was. And so I guess my point was that the approach has needed to be different, depending on the scenario. But how much it's integrated with other systems feels like the biggest factor.
Yeah. I think the common point I'm hearing in all of this is you really have to take it seriously and invest in these things.
Yeah.
And what I see, I'm that point of needing a substantial amount of test data in place in order to test that your searches work and that your various queries work is one I see often. But usually what I see is people just clone their production database in some way. And then, of course, you've got PII, personal information.
So, that was going to be the other thing I said. Or if you have if it's anything financial or PII, then you have to have a scrubbing process of some sort,
Yeah. So the company I'm looking at right now, it is a financial company, and they do have PII concerns. I think that's why they've only got really 2 or 3 environments for dozens of teams that they all sort of share. And the way they manage their data, I think, is fairly ad hoc. Is when they need something, they put something into the database. Of course, a lot of them are doing manual tests, and then they step on each other's toes, because if you're doing a search and you're assuming certain data is there, and somebody else has just inserted new data for their thing, then it doesn't work properly. So, yeah. Thanks very much for your comments, Sarah. Jay, also, I appreciate your participation today. We are out of time, so that is it for today. Now, we are going to be going on a short hiatus for the rest of February. I want to catch up on my backlog of recordings, and I'm trying to arrange some cool stuff that I'm not ready to announce yet for March. But the recordings are going to be going up on YouTube every week, so keep an eye on jamesshore.com, or follow the Discord, which is at jamesshore.com/s/AOAD2 Discord. Next week is going to be the recording of the pairing and mobbing session that we did with Woody Zuhl and Chris Lucian. And the week after that will be the user stories sessions. And like I said, I do hope to have some exciting announcements for March. I've got one lined up already, but I'm going to keep that in my back pocket. So keep an eye on the Discord for more information about that. That is it for this time. Thanks very much again, everybody, for participating. And I will see you all next time.